Hello, so let's look at today's lesson, which will be solving systems of equations using matrices. But before we jump into that, let's look at a warm-up problem where we were just solving matrix equations. Okay, there is a difference between those two, but we're going to look at solving matrix equations here. And so you have matrix A multiplied by some unknown matrix X, and it will equal a matrix B. So take a couple minutes, pause the video, and work on that. So hopefully that gave you enough time to solve that problem. Here we can see if we are trying to find the inverse of A to be able to get rid of A and isolate the X matrix. Okay, we find the determinant to be -1. We do the switch and the negate to get our inverse A matrix here. -1, 2, 2, -3. We multiply here both sides by A inverse. And once we've multiplied both sides by A inverse, we end up getting X equals this 2 by 2 matrix, 0, 9, 3, -14. And again, why is X isolated? Because A inverse times A gives me the identity matrix. So now let's move on to solving systems of linear equations using matrices. And you can see here are some steps to help solve this problem. So pause the video here if you'd like to put these into your notes here. But we can write the system as matrices where we have A is a coefficient matrix, and we'll talk about what that means. X is a matrix of variables, and B is a matrix of constants. Okay. Then we got to find the inverse of A, multiply each side by A inverse, and eventually you will find what that matrix X is. So here is a linear system of equations. Linear system, we have two linear equations, right, because there's no squared values, so just an X variable and a Y variable. And there are a couple different ways to solve these. In Algebra 1, you should have learned how to do substitution. You can also do elimination. In Algebra 2, we're not going to cover those, though you would like to know those methods to be able to help check. You can always go back. Khan Academy is a great place to look at those videos as well. Or come see me in tutorial for that type of help. So now let's look at this. So the first thing it said is we want to set this up in some. So we set this up in an A times X times B matrix, where A is the matrix of coefficients, B is the matrix of constants, and X is the matrix of variables. So what are coefficients? Well, if we look here, the coefficients, remember, are numbers that come right before our variables. So here, as I am looking at these, right, -2, 3, and 1. And so pretty much what we're going to do is we're just going to line them all up and put them in a matrix. So here, okay, this is our A matrix, right, because those are all coefficients. Well, we're going to put all the X coefficients of X columns in one column, so 2 and 5, and all the coefficients of the Y's in another column, so 3. And what's really there in front of that Y, since there's nothing there? Well, in that spot is a 1. So 3, 1. So there, now we set up matrix A. In matrix X, okay, this is our variable matrix, we'll have our variables. So in this case, it is 2 rows by 1 column. So it's the number of variables there are. So there's 2 different variables, X and Y, and each of them gets their own row. So if there had been 4 variables, X, Y, Z, and W, there would be a 1 by 4, or a 4 by 1, excuse me. Okay, finally, we're going to have some B matrix, which that's going to have all the constants. And constants in this case are going to be the things on the other side of the equal sign once we move all the variables to the other one. So here, this will be 11, and this will be 19. And so again, this is going to look like a column matrix. 11 and 19 in our column matrix. So here, 11 and 19. Well, at this point, now you just want to solve for X, just like we did before. So we need to find the inverse of A. So we're finding the inverse of A here. So the first thing we do is we need the determinant of A. So determinant A, again, we will get 1 over the determinant of A times when we switch and negate. So the determinant of A in this case is -2 minus A minus 15, so -16. So 1 over -16 times 1, -3, -5, -2. And A inverse becomes 1/16. So 1/16, -3 over 16, -5 over 16, and -1 over 8 because that fraction reduced. So that's A inverse. Well, now we just multiply both sides by A inverse. And all I'll do is I'm going to move over here to this other side so we have more room. I'll change colors. So now, when we look at this problem, we'll have this X matrix because X and Y, all we're doing is multiplying A inverse to both sides. And when you do that, right, it becomes the identity matrix leaving X alone times A inverse. So A inverse was 1/16, -3/16, -5/16, and 1/8 times RB. So 11, 19 there. So this is A inverse, and this is B, where this was our X matrix. Now, can we do this problem? Well, the first thing you can always check if you're not sure, and you look, it will work because here, these insides line up. They're equal. So we can do the problem. So now we would have 11, so row 1, column 1. So X, Y, so here's our X matrix, would equal, well, 11/16 plus, okay, 11/16 plus 3 times 19. So 11/16 plus a -57/16. So that's row 1, column 1. And in row 2, column 1, because our answer is only going to be a 2 by 1, we would get -55/16 and 19/8. So plus 19/8. And so as you could reduce this, so you would get so this here should be 17 over 16, -17 over 16, and all that's left is to simplify our fractions, which X and Y, and that should equal 23 over 8 and -17 over 16. And now you see you have two matrices that are both 2 by 1s, and they're equal to each other, so you can pull out X. Okay, here, let's try it again. Are we good? Here you go, you gotta count. Okay, so X is equal to 23 over 8, and Y is equal to -17 over 16. So, now, why don't you try this problem on your own? So here you should find the answers to that problem, and you can see that X is equal to 52 over 17, and Y is equal to 2.